Hey guys, I thought I'd take advantage of the working at home coronavirus situation and do something a little bit special for you guys. I've been picking up a lot of Predictas lately in various states in various states, let's just say, some well beyond repair, some supposedly had been working and had been restored. This is not one of those. So I thought I would attempt to get this thing up and running in rapid fashion rather than doing my usual stripping it down and replacing everything before even trying to power it up. I'm going to try to take this in phases. So this is the set that looked horrific when I got it. It came from Indiana. Came from kind of a thrift shop. It was cheap, and it looked like crap when I got it. I've done a lot of cleaning on this, and I still have a lot of cleaning to do. The whole thing looked like that when I got it. This has been cleaned. It's still not as white as it should be, and it has not been. Even where it looks kind of gold, this is not as clean as it should be. I don't know how it got in this state. You can watch part one when I got it, and I talk more about it. Potentially it was a smoker. If it was a smoker, I mean, my God. But maybe it was in a bar or something like that, so it was dozens of people smoking for dozens of years. I don't know. But it has had work done in the past. It's got a replacement CRT in it. Unfortunately, somebody ran it after the vertical circuit failed and burned a line into it, but it tests really good, so I'll leave it in there for now. Basically, I want to pull out the chassis, and first thing, work on the power supply. And then examine the main circuit boards, look for any obvious failure points, and try powering this thing up. Alright, let's see what we got to work with. It's been a little while since I looked at the chassis, so I don't quite remember what the state of it was. Also, I don't know what it is about these Predictas, but 17-inch sets, I think almost every one I've got is missing one foot. This is no exception. Front foot here. So that's why it's kind of flopping around. I think I left all the screws out of it, so it should come out yeah. So when you want to take one of these apart, just briefly, there are some cables coming down from the CRT, the swivel CRT. Plugs in here, one here, and then a high voltage line. I think I've got all those out. Connections to the speakers I plug up front, and there's a control harness here, and a tuner which I appear to have taken out. And also there's enough slack on the wires you can kind of start pulling it out even without everything being completely disconnected. But yeah, that's what I thought. I left this in a state of being disassembled. Now, this leads to something curious. So, I was talking with somebody who also has a Siesta, a restored one. We were talking about power for these. And he was saying the power switch is, the power is completely controlled by the clock. This has a clock built into it with a timer function which can turn the TV on or off at predetermined times. But I said, no, there's also a power switch in the control harness. And yeah, it's push on, push off, and there are the two wires for power. He said his didn't have that. The reason I got to talking about it, there was a set online somebody had a photo of had a switch added to the side, and they said that was probably to replace the damaged power switch, because it's one of the design flaws in these sets is the push on off power. These fail, so I've often seen them, either they short this out and people just plug or unplug the set or have it go to a power strip, or they add a switch somewhere else. So yeah, I gotta say, I've got one other Siesta set that's working, and I'm pretty sure it has a push on off power as well. So I think when you use the clock portion, you leave this switch in the on position, and then the clock will do its thing. I don't know. So anyways, so I left this in a state of easy removal, so that part of it's done already. Now when it comes time to power this up, I've got some CRT heads that I salvaged out of other sets, so I don't have to take this completely apart. I think I've also got a spare speaker handy. And see this over here, a little bit closer for you. This goes to that clock mechanism up front, and this is one of the control arms for it. And this is looks just like an AC interlock, because yeah, this goes to the power circuitry of the set. So they got some service info. Let's take a closer look at the chassis. So notice this floating around in here. Ah, I see. So I'm not sure if these two go together or what happened exactly with these sets. I know this clock part was kind of prone to failure, so I'm not sure what this is all about. I was going to figure, where the heck did I put the tuner? It's got to be down here somewhere. That's why I should never do this. Start taking a set apart, the thought I'd work on it and then letting it sit for ages. I don't remember where everything is. Briefly, power supply. This does have a power transformer. We've got a voltage doubler. Here's one of the caps for it. This is the one that goes right on the AC. A couple diodes buried down in here. Fusible resistor goes in here. Here's another one of the caps for the power supply, and here is the final multi-suction cap for the power supply. IF circuitry in here almost never goes bad. There are no paper caps in here. They call these perma circuits back in the day. They weren't really ever meant to need to be serviced. That's why they kind of built these sets the way they did. They're pretty darn reliable. The alignment on this, these screws anyways, is actually variable capacitors. And I rarely need an alignment touch-up on that, so I don't think we need to do anything in here except maybe check the tubes. So I'll be replacing these caps and the diodes and putting a new fusible resistor in there. There's a filter choke for the power supply here as well. So that's that part of it. And on this end, we've got the dreaded circuit board you've probably heard so much about that, oh my god, it's so hard to work on. Well, yeah, mainly because the other side of this chassis is metal. With some creativity, you can get in and get some of it. I've seen some of these where somebody hacked out the metal here to get at other parts of it. And why not just take the board out? Well, that's a little tricky, but by no means the end of the world. Especially after you've done it a few times, it gets to be pretty routine. So, on this circuit board, so this whole thing is one big circuit board. There are some metal stakes that come up from the chassis and they're bent over and soldered down. Those are grounding stakes that both hold this board in place and provide ground. That's why you can't just lift it out. It's not screwed down. It's actually metal bent over and soldered. There's like 8 points around here. And the other thing is the way the wiring is attached to the rest of the chassis, it's wire wrapped. So there are metal stakes sticking out with wires wrapped around them. So to take this out, you got to unwrap about 25, 30 wires and then hook them back in. These wires are somewhat different color, but over time they kind of lose that and they all sort of look the same. I'm also kind of curious because I got a Princess recently and that had plastic wiring and all the wires were pretty distinctive with their coloring, but this is all cloth covered wiring and it's all sort of beige. I think some of it has some stripes on it, but it all looks to be pretty much the same color with the exception of some coax here and there. That's interesting. Let's really get in here for a closer look. Before I do any work, I want to clean this up a bit and examine things. Well, it's kind of an odd tube. The 6FD7 Let me grab the service info for this. I feel very fortunate to have some of these Philco pocket service guides covering 58 through the early 60s. What this has is every model TV they made during that time frame with a miniature compact service info. Generally enough to get it going. I believe is a 41? 10L43, so I stand corrected. Now it's small, but this has everything. Every component is labeled and identified, including all the points where the wire stakes go. And there's a control harness, on-off volume control, so right there. That does have on-off functionality on it. Fusible resistor and so on. And then over here we have a fold-out schematic. A little bit of rust on it from the staples. So, I was curious about that tube. I believe that is the vertical output tube next to the vertical output transformer. But I'm pretty sure this set uses a 6DR7. Yeah. So, 6FD7 may very well be a compatible substitute for it. We'll have to check that out. Also note that they show a 5U4. I've never seen one of these in the flesh, but yes, the earliest versions of this used a rectifier tube. Shortly thereafter, they switched to power either germanium or silicon diodes, like this set has. So they mention an inset, yes, so we have this circuit to go off of. So I was curious, it's a voltage doubler, but it does have a power transformer. Used to seeing these going off right off of the AC line, but that's not how this goes. So there's our fusible resistor, 2 power diodes, our 2 electrolytics for the voltage doubler, filter choke, and a final filter cap. So we definitely want to probably end up replacing all this with the exception of the filter choke. And then there's that video IF panel. I said rarely needs any work done. And then everything else, all inside this dashed line here, that is what's on the circuit board. And all these points around here, L43, L35, L42, and so on, those correspond to the stakes around the board where wires are attached. So as I say, once you've worked on a few of these, it doesn't seem so daunting, I find anyways. They might be labeled on here. This one's so dirty it's hard to tell. I think they are to some extent. Like that says B+ next to it, but I don't think they have the same designations of the L series on here. But generally, I think it's pretty easy to trace out the wiring in these. Here's a parts locator. It's blown up, larger version, again with every point labeled, all the stakes for the wire wraps, all the individual parts. There's the IF board. There's some details about how the CRT head assembly goes. So it looks like they don't have anything in here about the Siesta clock and timer functionality. Huh. I got this for a remote manual switch cable assembly for like a hardwired remote control. I don't see the motorized clock. Huh. Well, I know I can find it in Sam's. Anyways, so closer look at this. There has been some work done. I see one replaced part here, and that was one of the recommended techniques for working on these. If a cap goes bad, you can clip it out from the top and solder a new one from the top side. And that works pretty well for a lot of these components. Even the resistors, if you're careful, you can do that. The tricky thing, though, is these guys. The other dreaded thing about these sets, the couplates. In order to make these more compact and to streamline production, they made use of about half a dozen of these couplates. What are these? Multiple components on one subassembly. Pretty easy to see on this. There's 4 parts in there. Either tubular ceramic type capacitors or resistors on a substrate connected together, and then there's little wires coming up from below into the circuit board. That one is especially prone to failure. It's in the vertical feedback. There's some high voltage pulses that go through it, so that's one that's typically replaced. There's a vertical integrator, another one that should be replaced. These are less prone to failure. It's in a horizontal oscillator circuit. And then there's one over here, which I think is part of the sync separator. So, I'm going to try getting this working without doing anything on this. I'm just going to work on the power supply first off, and I'm going to examine what's in here. The lead to the plate cap on the horizontal output tube seems a little loose. Also, this damper tube was kind of bent over. I think that's what the original tube was now. Originally had a 6DA4 in here. This has a 6AU4. I think they're compatible, but I want to double check on that. And I also wanted to show you something. If you determine or decide that you do want to replace these couplates, or K-networks they're sometimes called, you can roll your own. They are shown on the schematic, like there's one inside here, or in here. So here's that one in particular. It has the 4 parts, 2 resistors, 2 capacitors. So you could certainly get those components, make a little circuit board or perf board, or even just wire them in space and replace it. But I want to give a little plug to the TV restorer guy. He has manufactured excellent replacements and has them for sale. So saves you a lot of time and effort. And you can see how he made these. He made little circuit boards and placed the components on them, and then encapsulated them in epoxy and painted them and hand wrote on the part numbers. So huge time saver. This will be my first time using them. I bought one set for a holiday set you'll be seeing in the not too distant future, and I got one set for this guy. So, but again, I'm going to try getting this to do something before I install those. Ooh, just noticed that got a bit bent at some point in this set's life. So straighten that out a little bit. So first order of business, some cleaning. I'm going to use a soft brush and vacuum cleaner. Sometimes these boards, that's all they need. Sometimes, like on this one, I suspect it's a little bit trickier. These are phenolic circuit boards, and over time, from dust and whatever, stuff can get it's a little stubborn to get off. Q-tips and isopropyl alcohol is a good place to start. If you need to, maybe go a little more extreme with something like lacquer thinner, but be careful because that can eat away at plastics and such. Oh man, that's a drag. That could be a potential problem. Well, I do have a spare chassis or 2, but that is the horizontal oscillator coil, and it has a cracked core. Now, to right at the top, we don't know what condition is down inside. That may affect the resonant frequency. It may be subtle enough that we can compensate for it by just moving the slug up or down. But that is something to take note of. One nice thing about working on these sets is you can get the whole high voltage box off without with just a few sheet metal screws. So now we can really see in there. There's a hardened bit of insulation around the horizontal output tube. Lead. And flowback doesn't look too bad. May look bad to you, but trust me, as far as the vintage TV flyback goes, that's not so bad. A little bit of wax coming off is no big deal. That probably came off from up around in here. Another bit of it. Okay, it came off around the bottom. So a real easy thing to do with these is to get yourself some Corona dope. It's like really thick lacquer. It's got pretty high solvent VOC content, and it's got well, what am I trying to say? It resists high voltage. It has high insulation properties. It's like nail polish. You just paint it on and you're done. I would not get too obsessive about trying to chip off all this old coating. In the past, I'd gotten some RTV 133, I think it was, and I completely removed all the wax and put that on. That's expensive stuff. It's really overkill for this. Just slap on some Corona dope and you'll be fine. That's what it's made for. I don't have any because the one downside to it is it comes in a little bottle, glass bottle about yay big. And it's tightly sealed. Once you open it and break that seal, I find it very hard to re-seal it such that the solvents don't escape. So my bottle is all hardened up. But anyways, with that out of the way, I can really get in here and clean out the last bits of dust. I think these are replacement diodes. Yeah, I'm sure they are. You can see where parts have been clipped out. And unmounted this cap, got it totally out of the way. 200 microfarad, 150 volts. A few spots of corrosion here and there, but not too bad. So I'll get out the vacuum and clean this off a bit more, and pretty soon I'll actually start doing some work. Oh yeah, I want to dig out that other chassis to use as a reference. I guess you could think of this as a before and after. This is another 10L43 chassis. This is out of my Princess set that I restored a few years ago. And I want to show you what one looks like when it's all cleaned up. You see this one also has the cloth wiring predominantly, although this one's in considerably cleaner. So I guess the wires do have subtle color differences. They do have stripes on them, but this one's so filthy. I don't know if this is even cleanable. Let's see, a few other things of note. Here are some of those cup plates that I had made reproductions of on little perf boards, and the electrolytics. So here are the two for the voltage doublet power supply, and here's one of the others, and a couple down in here, and three of them very conveniently located on the circuit board. This is the circuit we're going to be working on first. So we're going to need a 5.6 ohm fusistor, aka a fusible resistor, a couple rectifiers, a couple 200 microfarad 150 volt caps, and an 80 microfarad 350 volt cap. Well, first let's talk about the fusible resistor. The reason that is there is to reduce the surge current going to the rectifiers. So when you turn the set on and the cap is discharged, especially that first one, the rectifiers don't pop. It's also there in case something dead shorts. It acts as a fuse. Well, modern rectifiers can handle surge current a lot better than the early types. And these especially, these are 3 amp diodes. These are 1N5408s. So the value is not critical at all. It's far more common to find a 7.5 ohm fusible resistor. Those will work just fine in this application. Luckily, I have some. They don't really make these anymore, not in this style that would fit right into the original socket down in there. You'd certainly make your own. You could just put a fuse in there. You could put a fuse in series with a thermistor, which would give this set a bit of a soft start, or you could just use simply a power resistor in series with a fuse. But since I've got some of these, that's what I'm going to use. And as I said, for the diodes, 3 amp diodes, these are 1N5408s, rated for 3 amps at 1000 volts. Overkill, but hey, why not? They only cost a few cents. And caps. 200 microfarad and 80 microfarad aren't standard values made these days, so we're going to go with the closest equivalent, which is 220. And I like to go a little bit higher on the voltage spec, so I'm using 250 volt caps. And for the 80, we're using an 82, rated for 400 volts. Now, going off my reference chassis over here, I can see that I found a place to mount the caps and the diodes down in this terminal strip. And this is what the original fusible resistor would have looked like in this set. And the 80, or 82, actually ends up over here. So that's what we're going to do. This cap will get involved later on. It actually goes to circuitry way over there. So you see on this side, there's 3 sections of that cap. The wiring I removed from here entirely and rerouted it elsewhere. I gotta say, this chassis does have a bit of an odor to it. I think it would benefit from a good cleaning. My friend had brought some Simply Green over the other day when we were working on his radio. I think a dose of that or some Pine Sol would help. And I know of one restorer, actually the guy who made those replica networks, who takes his chassis over to a car wash. I'm not quite that bold. I know he's had good luck with it. I know others have taken a garden hose to chassis, and if you let them dry out, they should be fine. I'm a little concerned about damaging fragile wires, so I'm not. But I do expect when this set is up and running and gets warm, it's going to smell interesting, let's say. So I'm going to get right in here and remove everything from this terminal strip. The wiring, the old diodes. Having my reference chassis is definitely a luxury. Otherwise, I'd be having to peer at that tiny service info. And I could certainly take that over to Kinko's or something and get it enlarged, which would be helpful. It would also help me preserve the old service info. I generally don't like having original vintage service information, documentation up on the workbench, because it can get damaged. But with everything kind of shut down right now, I don't think I'm going to be doing that. I'm not going to risk going out into public to get a photocopy made. Not that I'm actually really concerned. I mean, sure, take sensible precautions, but like working from home, washing your hands, I'm not hoarding toilet paper or anything like that. Although actually we're starting to get a little bit low, so I hope the stores restock soon. I don't know if you noticed what I did right there. Sometimes it's a little bit hard to get an old solder joint to melt. One thing that can help is to actually add more solder to it. So I fed a little bit in. It gives you a larger molten surface area to work with. There we go, almost. There we go. That's a big old kludge, because that's where they clipped out the old diodes and left the leads there and just globbed the new ones on top. Well, I'm going to remove all that. Speaking of that cap, I'm going to take it out right now. No, I'm not restuffing these caps. I don't think it's worth the effort. I've already clipped these wires out. This thing wasn't, I wonder if this is a replacement. I noticed it was kind of loose. And none of these lugs are actually soldered on. And this one has a little bit of solder on it, but the others don't have any. The wiring looks original though. So the one wire that was here, that's the one that's going to chassis lug on that terminal strip. Almost got it. A little bit of solder and remains of that wire on this one are kind of impeding its removal. Try to clip that out. Alright, just break it off. Pardon my clumsiness, but doing this stuff on camera makes it a little bit more awkward because the camera is kind of obscuring my field of view at times. I think we'll just break this off. Yep. Sure doesn't weigh much, but this is dried out. Let's get a nice dent in the side too. 10 microfarad, 450 volts, 20 microfarad at 350, and 100 microfarad at 50. So I'll need to dig up 3 caps to replace this guy. And these 3 wires that went here, I know on the other set that I pulled them out and routed them elsewhere. Some of those I think are the caps that ended up on that circuit board down below. So in some regards, at least, or maybe in all the case for all 3 caps, it's actually an improvement. Because the way it's working now is the caps are needed down here, but there was nowhere to mount them because the cap's too big. So they had to run wires from here all the way to here. Well, runs of long wires going to bypass caps is not a good idea because they've got resistance, they've got impedance, they pick up noise. So, alright, so I'm going to pull those wires out now. Get them out of the way. And again, open things up down here even more. Make sure I pull the right ones. I made some pretty good progress. I replaced both diodes, got the 2 new caps for the voltage doubler, new fusible resistor, pulled out those 3 wires that have been going to the cap over here, and a little bit of cleaning. One thing I noticed was curious is when I was starting to place the components like on this chassis, things weren't working out too well. And then I realized it's the placement of the terminal strip that's different. Look how close the terminal strip is to the IF shield in this one. It's only about a 1/4 inch away. On this one, it's about a good inch. In other words, it's over this way a lot more, which actually makes it easier to work on. So I had plenty of room for the diodes on this side, and the 2 caps fit very nicely over there, whereas on this one I had to kind of get a little more creative working things down in here. And this cleaning, yeah, I just couldn't resist, so I tried a few different things. Windex didn't do much of anything, but CLR did a pretty good job on this. I also tried using Spray 9, which is a pretty strong cleaner, which worked, but the best thing was CLR, calcium lime and rust remover. And the top of this transformer I used lacquer thinner because it was mostly caked on kind of wax there. And I use lacquer thinner on these wires as well. Again, you want to use it sparingly. It's a little intense. I cleaned up the tubes and checked the tube sockets while I was at it and straightened out the tube pins. And one thing occurred to me. So we know the vertical failed on this. So hopefully it's because of that common failure point, which are these vertical, these 2 couplets over here in the vertical circuit. But the fact that there's kind of an oddball replacement tube here, and this vertical output transformer looks a little crummy, I'm hoping that there isn't a short in here. By way of comparison, you see in this one, that's what a 6DR7 looks like. And you can see this tube is considerably larger. Now, underneath, it's a 9-pin tube, but it looks pretty beefy inside. Kind of curious too. So 6DR7 is a combination vertical oscillator and vertical output. And this one, it looks pretty obvious that one is a lot larger than the other. I'm assuming that the smaller one is for the vertical oscillator and the large one is the vertical output. On the 6DR7 though, I don't think it's quite as pronounced. No, there is a difference in this as well. Okay. I'm guessing the specs on this though are a lot more powerful. This is probably meant for a larger TV. I'll have to look at the specs on that. A 6FD7. Here's another progress update and a few tips. One, I took a chunk of the broken off wax and remelted it over the lead here that was a little loose. Worked out just fine. In fact, I think if one was to carefully go over this with the right type of heat gun, you could kind of soften it and reflow the whole thing. Just want to be careful, don't get too hot, it's just going to drip and fall off. Or get it hot enough that you melt it all off and then recoat it with something of your own choosing, but I would be hesitant to go to that extreme. Something else I wanted to mention, if you want to use this technique of relocating the caps onto the circuit board, well, here's where they go. So, the 3-section cap I took out from here, the 3 wires running to it. They run down through here, loop around this terminal strip, go down through here, over through here, and all the way around. So here's one of them. Goes to this point. And here are the other 2. One is at this point, and one is at this point. So that's what I meant about improving the design. So instead of the filter cap for the audio output tube being here, is way the heck over here. Yes, I'm altering the original design. Yes, it's not 100% authentic. Yes, it might confuse a future tech down the road. I think it's a worthy trade-off. So on this board, this is where those 3 caps end up going. Now, because I'm not taking out this board just yet, I can't do that. So what I am going to do is simply cut off these wires, strip off the ends, and have 3 caps floating in space. Simple as that. Which leaves this guy, 4-section cap. One of them is taken care of by, I think it's this guy. One of them we're going to be putting over here. It's this guy on this chassis, which leaves 2 more. On this one, I did something I don't recommend. It's a little bit of a hack. I took the remains of the mounting plate here, and I used the grounding points for the 2 caps, and I just attached wires. You can see there's a splice in one of them there. This needs to be cleaned up. I'm not quite done with this set. So I do want to find a better solution for this one. I'll try to install a terminal strip or something. I did not find a good place on the circuit board for those 2 caps. But for now, again, to get this powered up, I'll just tack a couple in over here somewheres. Alright, now things are getting fun. While I've been tacking in these temporary capacitors, I noticed some issues, so I need to put in one more temp cap to this lug. While fishing around here, I noticed 2 things. One, this resistor looked kind of cracked and a little fried, so I went to investigate and noticed it's extremely loose on both ends. I checked continuity, and it's supposed to be 5.6. It's measuring closer to 6.8K. But much bigger issue is when I measured continuity between this point and this point, I got infinity. In other words, the traces on the other side of the circuit board are broken, and we're not getting a connection, because if I follow this trace, it snakes around over to here. I think we can peer around and confirm that from the other side in a moment. But before we do, there's another issue up in this corner. Something else I noticed is that the whole circuit board is a little wobbly in this corner. So here's one of those grounding stakes on these boards, and let's see if I can get this on camera here. The stake is broken. Which means part of the circuitry may not be getting grounded. There are ground traces that run throughout the circuit board, but I don't think they're continuous. I think it does rely on it being grounded at various points around the board. So we can just solder that back together. That's a trivial fix. But let's take a look at the other side and see about that wonky resistor. So there is metal right over it, but I think if we peer from the side here, maybe we can take a look-see in there. Yep, I can see it down below here. And actually the trace isn't broken. I don't know if you guys can see that. Try to zoom in even closer. Whoa. Come on, folks, there we go. The trace is intact. The little lead coming through is actually, it's like a cold solder joint. Now what about the other end of it? Ooh, that's tough to see. Pardon my head. Same issue. See if I can capture that. is, it's pretty deep in here. I don't know if you're going to be able to see that, but it's wiggling at the other end as well. I might be able to get a soldering iron in there and pop a new resistor in and repair that. So I said you can access a fair amount of this with the various cutouts on the backside. So you can do some repairs without taking the board off at all and replace some components, that's for sure. Before I remove that resistor, a word about how to safely remove components from one of these boards without lifting up the traces. These are early circuit boards. If you apply too much heat, too much pressure, the copper will separate from the phenolic, the circuit board material. So as you see, the leads are typically pushed through and bent over. Don't heat it up and rip the component out from the other side. You could use solder wick or a solder sucker, remove the solder, straighten out the lead, and pull it out from the other side. But an easier way to do it, for most of these, cut the lead off on the other side, flush to the board, heat it up, and just pull it out of this side with the lowest heat setting you can get away with. Being very little stress on the board, no issue with the lead being bent over, it'll just pop right out of the side. I got that resistor out without any trouble using the technique I just described. And boy, look at that circuit board and that resistor. That thing is really roasted. So what's it used for? Well, it says on the board right there, width control. That is in series with the width control. That is over here. So, since the resistor measures actually a little bit higher than it's supposed to, and it's roasted, I'm thinking something else is amiss. So that's it right there, R15A. So I think I better check that width control and associated circuitry. I checked the width control and it's just fine, so perhaps it was that broken ground connection that caused that resistor to fry. I finished replacing all the electrolytics, so I think it's time for a little insanity. So what have we done at this point? Replaced the rectifiers in the power supply, all the electrolytics, put a new fusible resistor in place, and replaced one fried resistor that wasn't connected anymore, and fixed a broken ground connection, and did a little bit of cleaning. So let's try power up. I removed the CRT from the set because it occurred to me this set has been modified to use this CRT. And by that I mean the original picture tube ran on 2.68 volts for the filament, whereas the replacement runs on 6.3. It's a pretty simple modification. This is where the CRT power connects. And if you trace out a wire, there is a tap on this transformer for 2.68 volts. All you got to do is move the filament supply for the CRT from the 2.68 volt tap to the 6.3 volt tap. I think you also have to switch G1 and G2 on some 17-inch CRTs. There are about a dozen that can work, or maybe more than a dozen that can work. They can work with a Predicta there. 17-inch, 120-degree deflection with a short neck. Some might stick out the back. Some will fit nicely. This one just fits in there. So let's get this going. So I gotta hook up everything for the CRT, which can be a little tricky because, well, normally the CRT sits right on top of the chassis. I got it off to the side, so I gotta do what I can to get the leads positioned. Huh, looks like we got a broken wire here too. I don't know what that's about. There's one funny looking wire. Well, let's get this plugged in. We're splicing that wire. An oddball connector. There we go. This is the CRT power. So that connector was the yoke. This is the CRT power. Like so. It's a high voltage lead here, which has gotten sticky. I'm going to clean that off because it's got some dog hair stuck on it, it looks like. And then this is video. I don't recall exactly where this hooks in, but this, I think, is a video out. It should be somewhere around here. There's a stake sticking up out of the board that you stick this onto. Oh, here it is. It's actually labeled vid out right here. That is going to be tough to reach. But you know what? We can leave that off for now, I think. Now, okay, what I'm going to have to do is, I know I've done this before. Maybe the leads were longer on that CRT. But if I go all the way up on the back like so, I can, I think, maybe make it reach. Slide this over. Oof, that's also really crummy. Oh, I think that's the wrong one. I think that's the broken off yoke wire. Alright, where'd that video lead go? It's high voltage. Oh, here we go. That's why it was so short. I had the wrong wire. So that goes on there. Yeah, I don't know what to do with this. For it's more clearance. So high voltage. These wires are all so stiff and crusty. I think, oh yeah, the insulation's actually cracking off. I think get some lacquer thinner and clean that off. I think what I'm going to be doing, assuming I can get some life out of this set, is replace all this wiring for the CRT. It's most of the wires are the same cloth covered stranded wire as the rest of this set. So you don't want to use solid wires because you want a little bit of give, because for the CRT rotating back and forth. But these are just with age and heat and God knows what kind of environment this thing was exposed to. Insulation is not in very good shape. So there's goo that accumulates on old plastic wires. As near as I can figure is the old, or the plasticizer leaching out of the plastic. It's very sticky, and that's why dirt adheres to it so well. So this actually, this wire should be bright red, but it's black from all the junk on it. Hardly unique to Predictas. Boy, that Admiral I worked on recently, 21-inch Admiral, was incredibly sticky all over. Okay, so I got to get this over here without it breaking off too badly. Needs to go down into, there's a pin in the high voltage tube socket for that wire. Okay, and high voltage rectifier tube. So what do I think's going to happen? Whew. I have no idea. Considering the state of this thing, well, for one, if the power switch is no good, nothing's going to happen. And I should do a test first without the fusible resistor to see if the tubes even light up. But I have not tested the power transformer. Here's the tuner. Oh, the things I do to entertain you guys. This is one of the more insane power-ups I've attempted. Depending on how this goes, I think what I will quickly be doing is verify how this is wired up with the CRT filament and G1, G2 wiring, and ditch this and use a known good head unit, because this wiring is so bad, and it'll take some work to rewire it, especially because the horizontal yoke wiring seems to be especially thick, so I'm thinking maybe it's more than 600 volt wire, and I don't know if I have appropriate wire handy. Okay, I am going to kill some of the lighting. So the fusible resistor is out. We are just going to be looking for filament glow. I've got it plugged into my Variac so I can monitor the output current. And it is on. We have 0 current draw. I'm going to try hitting the power switch. We have current draw of about 1/2 amp. And I see tube glowage. Let's kill some of the lights. Tuner lights, the IF tubes, looks like the damper might be out in the horizontal output tube, and this 6CG7 maybe? No? Oh, okay, there goes the horizontal output tube. I'm thinking we could have some kind of bad socket connectivity. Well, since I've got that spare chassis nearby, I can swap some tubes out. Looks like we just have 2 tubes that aren't lit up right now. Alright, that's something. I'm also amazed that the power switch is good. I was just on the verge of giving up when I managed to get both tubes to light. Tube sockets on these predictors can be a little flaky. I had to tighten up the filament pins on the damper tube by kind of bending the metal a little bit, so I definitely want to be replacing that one. And I think the same for this one. Also, this tube is really dim, so it's just kind of hard to tell when it's lit. But every tube is lit up as we speak. I also went ahead and hooked up a speaker, because hey, why not be optimistic? So we're going to turn this off. I've got my trusty Fluke 27 on the main B plus supply. Here is the fusible resistor to turn this a little so you can see the meter. On the workbench. Okay, so this is going in. So, and recently I powered up Predicta Princess, and I said there's no way to tell when they're turned on. There actually should be a light in here, but they're so often burned out, including this one. But there is a little light bulb down in there by the channel indicator. Alright, well, here we go. Current shot up higher than before. We've got 300 volts. It's dropping a bit as the tubes are starting to draw some current. Holding steady at about 272. Nothing smoking. We have cracklage out of the speaker. I get the sense we don't have any high voltage on the damper tube went out. It's lit up again. And it went out again. There's metal on the other side of it. I can't get at it without taking the board out, I'm afraid. Damn it, it's annoying. Our damper tube, I don't think you can't get high voltage, I'm pretty sure. If I keep pressing my finger on it, it seems like I can keep it lit up. Not particularly crazy. Whoa, hey, we have a line. The line that's seared, and there it goes with the damper tube out. So, I will swap out that vertical output tube. I hope you guys got to see that. There was a bright horizontal line. Remember the CRT has one burned in. Let's get rid of this goofy looking vertical output tube and put it in a different one. Alright, power up test number 2 with a 6DR7. And I put on a channel clunker and fine tuning knobs so I can manipulate the tuner, and I actually rigged up an antenna because, hey, why not be optimistic? Maybe even if we can't get vertical deflection, maybe we can actually receive something and get some audio out of this. Here goes the power. Damper tube is up again. Kind of found a sweet spot for the damper, I think. Yeah, if I kind of keep it there and sideways pressure on it. Oop, not anymore. Alright, fine. I'll just keep my finger next to the flyback. If that's what it's going to take, I'll make the sacrifice. Still on vertical deflection now. I'm going to cut the brightness down. This guy. Alright, so It could be a few things. Could be vertical oscillator. Could be the vertical output transformer. Could be the vertical yoke winding. Well, the tuner is actually doing something. Maybe I was being a little bit too optimistic. I can't tell where channels are on this thing. Boy, I can see how a trace got burned into this, because even with the brightness all the way down, it's still pretty darn bright. So I'm just going to let the damper fade out so we don't have high voltage. Well, it did a lot more than I thought it would. So you know, the flyback's good. Picture tube has life. I mean, I knew it was good, but it was nice to see some light come out of it. And the set is far more functional than I thought it would be, to the point where the tuner is even trying to do something. But now we've got the problem that you face when you work on a Predicta. What do you do to troubleshoot it? Yeah, I could measure voltages. I've got extender sockets, something like this, where you can put it between the tube and the circuit board so you can measure voltages. I can kind of clip and replace some parts from the top. But when it comes to the vertical, it's almost always these cup plates. I can't really replace them. Well, maybe I can. I'll see if I can get underneath the board and pop in those new ones. Maybe. And I will check the resistance on the vertical output transformer. Probably turn the set off as I'm poking my fingers in it. But you kind of reach a point where you gotta take the board out. We know that cracked horizontal oscillator slug certainly isn't a showstopper. But you kind of reach a point, especially with those metal on the bottom, where you can't get at stuff. You gotta take the board out. And once you go through the hassle of taking the board out, you shotgun it. I hate to say it, but I know it's not fun. You don't get to replace a few components and see if it fixed the problem or not, or things got any better. Once you've done a few, it's not horrible to take the board out, but you got to hook it all back up and then take it out again and again and again. That's a hassle. So I'm a little torn. Also realized I stole the AFC diodes out of this to do a power-up test on a Princess. So not that would prevent the vertical deflection from working, but it just occurred to me I forgot to put it back in. Hey, all in all, this was better than I expected it to be. I'm just not sure where all to go from here. I guess I will see if I can replace any of the vertical stuff. I think a couple of these caps I could probably clip out from above, and I could check some voltages, and as I said, check the resistance on this guy. And yeah, well, we'll see.